Okay, so the midterm exam will be the Wednesday on the 19th, and from 8 a.m. to 8:55 during the class time. So the materials to study will be quizzes 1 through 8, homework assignments 1 to 3, and lecture videos and notes. And that's it, very clear. Nothing will go beyond all these materials you guys studied in the class since the start of the semester. Okay, and so if we look at the structure of the midterm exam, and I'm trying to make it easier to follow and cover a broad range of stuff that we have learned since the start of the semester. So you can imagine that I cannot let you, like, for example, spend 15 minutes on each problem, and there are 8 problems, and they'll be easier than the quiz problems, or probably similar to the quiz problems. And I'm expecting, probably, if you use 55 divided by 8, right, it's about 7 minutes for each problem. But I think you can, for a lot of problems, you can probably get it done within like 2 minutes. So I'm trying to make the numbers easier to calculate, but keep in mind that no cheat sheet is allowed. Sorry. And it's closed book, closed notes. And calculator is allowed. Okay. Right. So now let's keep moving and look at the problems we can possibly be on the midterm exam. Okay. If you open up quiz 1, you can see it's a Thevenin's equivalent. And digital signal time delay. Okay, you need to know that equation, how to calculate time delay, but you're not required to remember how to derive it. And so for the time delay, the circuit will be a lot easier than whatever you saw from the quiz. Because you definitely don't have time to go through every single thing during the exam. We only have 55 minutes for the exam. But there's one more thing that I need to know, which is simulation related. For example, a pulse. You want to study pulse function. So the pulse function. Right? So what are the arguments in the pulse function? Okay, so the first one is you can open up, you can right click the pulse function in LT-SPICE and find out every single argument. So the first one is the initial voltage. So I expect you guys can figure this out during the exam, because we have been using this pulse function in electric VLSI for so many times in the labs. And so the arguments at each location represents a certain number. So that's the initial voltage, which means at the very beginning of the pulse, it was like, for example, 0 volts. If I put a 0 here, and then it jumps to 5 volts. Okay, so that's on voltage. And it's followed by a time delay. So for this, it means for this type of initial and on, and you want this one to happen after this certain amount of delay. And this one is the rising edge. and this is the falling edge. This one actually, the one next to it. Rising edge, falling edge, on time and period. This is on time, and this is period. So make sure that you know which argument means what, because I probably will ask you, what's the frequency of the signal? What's the rising edge time of the signal? Things like that. Okay, and so the pulse function argument is required. Okay, and DAC, R2R DAC. Okay. So you can see there's a homework assignment problem, there's a quiz, and so I expect that you can calculate the VL from the digital input. And derivation is not required. So basically, if I give you a digital code, for example, 101, 110, or whatever, okay, to find out the analog VL, it's pretty simple. So I expect you guys can get this done probably in 30 seconds or so, okay? Make sure you understand how that works. And next, the problem, so the next things we have learned is the C5 layers. So there are 3 metal layers. And from the very bottom, you have P sub, and then the one next to it is the Fox, the P sub, Fox, and then poly, and metal 1, metal 2, and metal 3. Okay, and there can be an opening here to hold a metal 3 as a bonding pads, so you can connect the wires to the outside circuits. So it's metal 3. Fox. It's poly. Fox. Poly. Metal 1, metal 2, metal 3. Okay. Just review all these quiz and homework problems. I think it will be good enough to prepare you for that problem on the midterm. For other ones, let me take a look. So you need to know IV curves of the NMOS and PMOS. We had a quiz on this. Remember that the VGS versus IDS curve for NMOS, there's a threshold voltage, VTH. Okay, so this is VGS, and this is IDS. For the VDS versus IDS, it looks like this. So this point, keep in mind, that's on the x-axis. Okay, so that voltage is VDS set. So for PMOS, you should be able to draw that as well. Okay, 2 other curves for PMOS. So the key point is where is the threshold voltage and where is the the point to enter the saturation region at VDS. So that's a two key point over here. And other things we have learned, for example, the diodes, right? Diodes, pin junctions, all these semiconductor fundamentals that you need to know. The depletion region, and the junction capacitance, and the diode clamping circuit. So you can find all this information from the lecture notes, okay? And next we moved on to the AOI logic. This happens most recently. AOI logic, schematic, and stick diagrams. So review all these lecture examples, lecture notes, quizzes, and homework assignments. Okay, so these should prepare you well for these problem on the midterm. So I saw a lot of issues when I graded all these assignments for the stick diagram related to problems, and I found out a few students are still not getting it at all. So make sure you can definitely convert a logic expression to the AOI logic and schematic and then stick diagram without any problems. Otherwise, you are losing like 10 points or 20 points for the midterm. It's gonna directly, make your grade way lower than whatever you are supposed to get. So make sure you study this, understand this. If you don't, watch the videos and do more practice, okay, on the paper. Important. And then other things you need to know, for example, the unwell resistors, time delay, sheet resistance, let me see anything else. ADC resolution, and inverters. Okay, so for inverters, review the notes regarding the switching point. Okay, so the key point is for inverter, it's gonna switch like this. Okay, and because mobility of the holes is less than the mobility of the electrons, and that is why you need a stronger PMOS to keep it switching at 2.5 volts over here. Okay, and so in that case, if I keep making the PMOS even more stronger, and in that case, it will hold the VD value for a longer time. So you can expect that if the PMOS is even more stronger, and so it's gonna hold the logic 1 for a longer period of time and eventually switch to 0. So it's making the switching point shifting to the right. And whenever you have a stronger NMOS, it's gonna drag it down to 0 earlier. So the switching point will be on the left hand side, and that's how you can understand this easily and also can figure out the problem on the midterm easily. So make sure you understand this, watch the videos, go through the notes, and prepare for the exam. So I think this is pretty much everything we have covered since the start of semester. A lot of things, but the midterm problems can be a lot easier than you thought. So study it, and hope everyone can get 100 on it. Okay.